Hello and welcome to the last day of the unit. We are on page 31 on day 8 and we're going to look at solving rational inequalities. The good news, you've already solved inequalities before. We did that with the radical ones. It's the same idea in the sense that you're going to be doing a number line and we're going to be writing it in interval notation. So if we look at the steps, we're going to write the inequality as an equation and solve the equation. That's going to be one critical point. Then we're going to determine any values that make the denominator equal 0. That's where a function is undefined. That's going to give us either one or more critical points. Then on a number line, we're going to mark each of the critical points. We're going to test it. Now, one of the things that you have to do here is make sure that we have, this is looking at original inequality sign to know whether it's open or closed. When the denominator is equal to 0, we will always have an open, I'm going to change color, open circle. Always. Okay? Because the function can never be defined where it's undefined, it's why it's always going to be an open circle. So if we look at this example, we have a common denominator. We have x plus 5 and 1. Therefore, our common denominator must be x plus 5. So we did x minus 4 over x plus 5 equals 4 times x plus 5 over x plus 5. Why did we do that? Well, we multiplied by x plus 5 over x plus 5 to make the denominators the same. When the denominators are the same, we can set the numerators equal to each other, so therefore x minus 4 equals 4 times x plus 5. We solve it to get x equals negative 8. It's open due to the fact of that inequality is just less than. Then we also set the denominator equal to 0. That's what we did here. This is going to be open also. So our two critical values are at negative 8 and negative 5. That should say negative 5. And then we test. You test at negative 9. Somewhere in between, we chose negative 6 and 0. Again, you can use y1 and y2. Right? We can go y1, put this into y2, and we're looking for when y1 is less than y2. Or you can plug in here. It's true, so smiley, x, smiley, and therefore we then can write it as x is less than negative 8 or x is greater than negative 5. And I know how you usually write it as an interval notation, negative infinity to negative 8, open, or negative 5 to infinity. So let's look at some examples. Our common denominator in this case, we have x, and a 1. Well, common denominator better be an x. So I'm going to multiply this by x over x. Now that all the denominators are the same, we can set the numerators equal. 3 plus 7 equals 9 times x. So we got 10 equals 9x, divided by 9, divided by 9, we're going to get x to equal 10 over 9. This is open. Why is it open? We have just a greater than. To set the denominator equal to 0, or where it's undefined, is at x equals 0. We only have an x in the denominator, so therefore x equals 0. It's already solved for. Again, open. Number line, 0 and 10/9. We're going to test. I'm going to test negative 1, 1, and 2. So if I test negative 1, 3 over negative 1 plus 7 over negative 1 is greater than 9. That's negative 10 is greater than 9. That's false. So I'm going to test 1 over here. 3 divided by 1 plus 7 divided by 1 is greater than 9. 10 is greater than 9. That's true. Now let's test 2. 3 divided by 2 plus 7 divided by 2 is greater than 9. It's 1.5. This is 3.5, 1.5, and 3.5 is 5. That is not greater than 9. That is false. And so my final answer is from 0 to 10 over 9 and in brackets. Or sorry, in parentheses. So we found a common denominator, which was x. We solved it. We found where it was undefined. Didn't have to do any solving there because we just set x equals 0. Put them on a number line, and then you test it. Please make sure you realize that you can use your calculator. I would suggest putting this into y1, this into y2, just like you're used to, and setting and showing that, showing the number line from there. For number 2, we have 5 divided by x minus 1 plus 1 is less than or equal to 0. Our common denominator here will be x minus 1. Why? Well, we have everything else divided by 1s. So we rewrite this as 5 over x minus 1 plus x minus 1 over x minus 1 is less than or equal to 0 times x minus 1 over x minus 1. Now that the denominators are the same, we can set the numerators and 0 times anything together. 0 times anything is 0. So 5 plus x minus 1 equals 0. We'll get 4 plus x to equal 0, and x equals negative 4. This is closed due to the fact that it's less than or equal to. To find where it's undefined, we're going to set x minus 1 equal to 0, and we'll get x equals 1. Remember that that's always open. So now we have negative 4 and 1. We will test. Let's try to test here. We'll test negative 5. We'll test 0. And we'll test 2. So negative 5, we're going to get 5 over negative 6 plus 1 is less than or equal to 0. In this case, we'll have 5 over negative 1 plus 1 is less than or equal to 0. And in this case, we'll have 5 over 1 plus 1 is less than or equal to 0. See here, we're going to get a number smaller than 1 plus 1 that is not less than 0. Here we'll have negative 5 plus 1 that is less than 0, so x, smiley face, and 5 plus 1 is 6, that's definitely not less than 0. So we'll get negative 4 to 1. It's closed at negative 4 and open to 1. And so that is our answer. And again, while I'm going through this, if I'm going too fast, you need to slow down, pause it, and make sure you're going over it to understand it. This is the last day, and you don't want to be confused. So just to recap, found a common denominator, set the numerators equal to each other, solved it, notice it was closed due to the less than or equal to sign, found where it was undefined, plugged those in on the number line, tested, again use your calculator if you want to, test it to make sure y1 was less than 0. That happens only in between negative 4 and 1, and so we have our answer. What I would like you to do right now is pause the video and attempt number 3, please. Please pause the video and attempt number 3. And here's the answer to number 3. Hopefully you realize that it was okay to get a decimal. So you should have had 3/10 or 0.3, and where it's undefined is 0. And so then you test numbers. Notice that I tested 0.1 here. So 1 divided by 0.1 is 10, and 1 divided by 0.2 is 5. You do have to find a number between 0 and 0.3. But hopefully you got 0 to 3/10, both excluded from the interval, so both parentheses. Why don't you guys do actually, we'll skip number 4. And let's do number 5. We can do number 5 together here. Notice that the denominator will put this over 1. Notice that you can multiply this by x plus 4 over x plus 4, but because it's 0, it does not matter. So we can set the numerator equal to 0. Notice it's a quadratic. You have an x squared and an x. We need to factor that. When you see that, you should automatically think factoring. Factors of 8 that subtract to give you 2, we know are 4 and 2. And we need to be negative 2, so it's 2 minus 4. I just put that in wrong. Set it correct and put it in wrong. 2 minus 4. When we have factors set equal to 0, you set each one equal to 0. We'll get x to equal 4 and x to equal negative 2. We also then have to find where it's undefined. To do where it's undefined. X plus 4 equals 0, and we go x equals negative 4. Undefined is always open, and because we have greater than or equal to, these are closed. So on our number line, we have negative 4, negative 2, and 4. We're closed at 4. We're closed at negative 2, and we're open at negative 4. This is the first time that we've had 3, so we need to make sure to test 4 numbers now. And so now our goal is to check to see which numbers work. So I'm going to test numbers less than negative 4, which I'm going to test negative 5. In between negative 4 and negative 2, let's go negative 3. Between negative 2 and 4, easiest one we can do is 0, and after 4 is 5. So let's test negative 5. Again, you can use this in your calculator. I'm going to go through it the long way. Negative 5 squared is 25. Negative 2 times 5 is 10, so 25 and 10 is 35 minus 8 is going to give us a positive 28 over negative 5 plus 4 is negative 1. Is that greater than 0? No, it is not, as in 28 divided by a negative is a negative number. Let's test negative 3. That's 9 plus 6 is 15 minus 8 is 9 plus 24 minus 8 is then 16 divided by negative 3 plus 4 is 1. Hey, that is greater than 0. A positive number is greater than 0. 0, we're going to get negative 8 over 4. Notice that those all go to 0, so you get negative 8 over 4. Is that greater than 0? Absolutely not. And then 5, we're going to get some large number on top. 5 squared plus 10, 35 minus 8. Again, give you 28 divided by 9. 28 divided by 9, is that greater than 0? And the answer is it is. So we know we're going to be where our smiley faces is between negative 4 and negative 2, and then after 4. So our final answer for number 5 will be from negative 4 to negative 2, including negative 2, excluding negative 4, or from 4 to infinity, including 4. Again, a faster way to do all of that is you can plug it in the calculator, test those numbers on the table, and see if they're greater than or equal to 0. So with that, we are done with Unit 3. Congrats. I will see you in class to go over any questions that you may have, but we are done, completed Unit 3. Well done, guys.